So welcome, my name's Eugene McCall. Today we're going to be going over the video solution to my blog on RESTCONF, specifically around Cisco IOS XE and the CSR 1000V platform that we're going to be utilizing from DevNet's Always On Sandbox. To get started today, you should probably have a firm grasp of network fundamentals. So understanding what static routing is, IPing interfaces, etc. Not going to be going over the theory on that one. Also, Python, Yang modeling, RESTCONF as a protocol. The expectation coming into this is that you probably know what those are and understand somewhat of the tree and can trace out a little bit in JSON. I'll cover some of that, but I'm not going to go into depth on the detail. So to that end, let's get into the lab and let's get started. All right, here we are. So I'm going to start off with the blog post because this is going to essentially be our lab guide. So I went over some of the beginning stuff already. The way I've broken this down is essentially you get two major problems. So this would be a task in a lab somewhere or on the DevNet core exam potentially. You'll note that as far as the exam topics go for the DevNet core, both of these are specifically pulled directly from the exam topics. Both the first one of setting a static route and the second one of setting an IP address for an interface. And from there, I've then broken these down into tasks. The first one, of course, starting with Postman, just to get us a foot in the door on this problem. And then moving forward with Python to actually perform and execute the configuration and cleanup tasks. So let's get started. As mentioned, we're going to use the DevNet Always On Sandbox. So this is the iOS XE on CSR latest code, Always On. And from this, we're going to start off by looking at the documentation briefly to give us a start. So information about RESTCONF. And what we're going to start off with is the root resource, just to get an understanding of what we need to do when we start making these calls to RESTCONF. And it's right off the bat, it gives you a nice little example here of your URL that you need, the IP address here. It needs to be RESTCONF data, and then Cisco IOS XE native, native. I believe that it's unique so that you can get away with just saying native, but we'll come back and utilize this in a minute. And so looking back at the details for access here, we have a URL, which is handy, that we can utilize, and a username and password that we can put in here. So let's copy this URL, come into Postman here. And I've got a new collection set up here. If you're not so familiar with Postman, it's basically a tool that allows you to build API calls pretty easily. You can go add a new collection. I've just got a CSR 1000V RESTCONF collection here. I'm going to go ahead and add a request to this. So I'm going to paste this URL in. We note that it's a GET request. Perfect. All right, let's go back to our instructions here and pull the username password down as well. Okay, so we're going to need that. And we're going to put that in authorization. And that's going to be basic auth. So developer. And as you see, I've actually already put these in here once, it looks like, even though it's a new request, and the password there. Additionally, on headers, we're not going to use this default accept. All right. Because if we roll down here, let's see, we've got methods. Here we are. So the resource. So it's the top level resources located at RESTCONF. That's what we just saw up here with the RESTCONF data and then model. But what's important on this line is that we have two ways to consume this information. Either we can use Yang data plus XML or Yang data plus JSON. So XML is the default, but it's pretty typical these days to start with JSON. So we're going to copy this directly in to two additional headers. One is going to be the content type. See there? Oopsie daisy. And the second is going to be our accept. Right, 'cause we don't actually want to accept everything like that does by default. Great. Now, the second thing we were just looking at, we need RESTCONF on here. So RESTCONF, then we're going to add data. You see I've already got this populated a little bit in there. Perfect. So now we have our URL properly applied. We've got application Yang data plus JSON and our content type accept header. We've got our authorization set up with basic authorization. So let's go ahead and send this off, and it should come back with an error if we give it a second. Let's see. Now, one thing that I did not do is, you see here we copied this, but I did not actually specify that this was supposed to be HTTPS. So you'll note if you just copy this and move on, this will eventually error, and essentially the error is just going to be a timeout. So I'm going to cancel that. I'm going to come back up in here, and I'm going to ensure that we're utilizing port 443 for RESTCONF, as they suggest to do here. For instance, if we were to do netconf, that's the standard port of 830. But for our purposes, we're utilizing RESTCONF on 443. Let's try it one more time. We should get another error here. And yes, indeed we do. So ironically, even though this is how they give you application Yang data plus JSON in the documentation, it actually has to be all lowercase like this. So let's copy this back in. And this is where Postman truly shines, is all of this is just easy copy paste into a nice beautiful GUI until you get the right call. And here we go. We finally got some data back. So this is our Yang model, specifically the iOS XE native Yang model. So we can see that we have different configurations that, if you're familiar with Cisco networking fundamentals, as you should be, will make a lot of sense to you. Essentially, all of our top-level configurable items are also top-level Yang items, and container as such in here. So what we're interested in doing today is setting a static route, at least in the initial problem. So let's keep scrolling until, here we go. So under native IP route, we see this IP route interface forwarding list. And underneath here, we see that we have a static route. So let's go ahead and drill down a little bit further so that we can pull out just the specific information we want. So we know up here it's IP route. Let's go ahead and send that back off. And yeah, we get a much shorter list here. This is much easier to manage. Specifically, we could also tag on this IP route interface forwarding list. And this is just going to pull back the actual list here. Now you see this is just specifically our static routes. Again, at the moment, consisting of a single static route. All right, now that we have our static route information pulled back, let's go back and see what the next task is in our lab. So task 2 is updating the URL to only pull down IP routing information. Well, we already did that, didn't we? So investigate the options, right? Like setting next hop IP address, using an interface, giving the route a name, etc. Let's look real quick to see what those are. So yeah, of course. All right, so prefix and mask. So IP route, blah, 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 space mask, blah, blah, blah. Without the keyword of mask, of course, when you're doing it on the command line. Forward list, okay, so we can set our next hop as a interface. Of course, we know from network fundamentals that we can do that, or set an IP route. What's interesting about this is that this forward command, or key, I should say, is in this dictionary here, which of course is in this list. But when it's set to an interface, we note that we need an interface next hop configured separately. So we'll get to that in a little bit. But for the meantime, let's go back and see what we're doing here. Task 3. Okay, switch to Python and create a new file with the name of getStaticRoute.py. And configure a script to pull down the same information we explored in Postman. And we can generate the code in Postman, ensuring we're using the auth equals username password and verify equals false parameters inside the request. Now that's actually kind of important here. We'll see that this is going to be given to us by Postman, but we'll see what happens if we don't throw in the verify equals false, because that's not given to us by Postman specifically. So within Postman, if you're not already aware, you can go up to this little code button, and I'm going to use the Python requests library. Let's simply just copy this over. Now over in VS Code, I have a new folder set up here called eMcCall Lab, and I'm just going to come up here and create a new file, and we saw that was getStaticRoute.py. I believe it was. Let's verify that. GetStaticRoute.py. Perfect. So back to our VS Code. We're just going to paste in the Python that we got out of Postman from the request that we built. And notice we actually get this basic auth header that Postman does. This is just encoded username password into base 64 that we had originally put into Postman underneath the authorization tab here. So they just base 64 encoded this and put this into the header, which actually serves us well. Instead of having to come in here and add another auth equals username password, similar to how I said here. This gives us the ability to just ignore that, put it in our headers natively, utilizing our encoding. Perfect. One thing I am going to adjust from here is instead of doing a request.request specifying a get, I think it's a little redundant personally. There's probably a good reason for it that I just don't know. But for me, in these labs, I'm just going to use the request dot method. So specifically in this case, it's get. We note that our content type and accept headers are explicitly defined here, which is important. And then our URL up here is also defined for us. We're importing the requests library and JSON library. We're going and doing a response equals request.get. So this response is going to give us back a get with the headers defined here, our payload defined here, and the URL defined here. Cool. We're going to print that out as a text file. Now note, I have not changed anything else outside of just the get method, put that up front. So this is practically what we've got natively from Postman. We'll run this, just a little debug here, and we know that, well, we have an exception here, obviously an error, and it was caused by the certificate verify failed. So this is not we do not have the ability to verify the certificate coming off this CSR 1000V via some CA chain, etc. So we're just going to come in here, because this is a lab environment. You wouldn't necessarily want to do this in production. You'd want to get an actual certificate that's part of your CA chain on your devices, but for now we're just going to verify equals false. So let's go ahead and clear this, run this again, and note that we get the same output as we saw in Postman, with one addition. It's warnings.warn. It's not a big deal. This is just telling us, hey, the certificate's not valid. It's not been able to be verified, just so you're aware. If we want to get rid of that, we can import URL lib3 and just do URL lib3 dot disable warnings. That's what it is. And we'll save that, run it again, just so you guys can see. And yeah, so that's gone now, and we just get the data back. So that's pretty clean. Now that we've gotten our static routes, let's go back and see what is next. Task 4. So we're going to copy this code into a new file. We're going to do set static route.py. We're going to create a Python dictionary and input the necessary parameters to configure the following static route. So IP route blah. Okay, let's look at our hint real quick. Configure the route and see how the router represents the parameters in Yang. So this is important simply because if we look back and we run this again, we see a distinct difference between what we want to configure and what's configured currently in the default static route. And we mentioned this earlier, but just to review, we've had a forward to an interface, and then within that interface, we've given it an next hop of this IP address. We're clearly not going to be forwarding to an interface here, and we just want to forward it directly to a next hop IP address. So, oops, daisy, let's see. Let's go over to our secure CRT and configure that real quick. So we want an IP route of 10.100.100.0 with the 255.255.255.0 mask going to 17.17.17.17. We want to give it the name of, let's go back and look, RESTCONF test route. Fantastic. If we do a show run, include IP route real quick, we see, okay, yes, that is in there. Awesome. So let's pull this to the side one more time. Go back to our Visual Studio Code. We're going to run this get static route. And we see, oh great, now we have our new static route in there. And note that this forward list, instead of an interface and then interface next hop, we just have forwarding it to an IP address and name. This is going to be important to us. So following on the lab, we're going to take this. We're going to, I already have it somewhat set up here. Paste it in here. Fantastic. So a couple things we need to do. First, we need to change this payload. We noted we're already sending a payload, but in a GET request, it's not really going to care about our payload, so we're going to change that payload here. Now, it's important here that we look under our IP route interface forwarding list. We see initially we have this list item that we need to put into place in our structure. So we're going to first add that. So we know we're adding to this list here. And then we're just going to follow it down. So we're creating a dictionary within this list. The dictionary is going to have a few key value pairs here. The prefix, which we know is 10.100.100.0. And then we have our mask, which is 255.255.255.0. And then we have our forward list, which is the values of list in there. And within this list, forward list, we see we actually have another dictionary within that list with key value pairs. So in here, we're going to do forward of 17, 17, 17, 17. Right? And then we're going to give it a name of RESTCONF test route. Beautiful. If you didn't need to do this, congratulations. For me, this confused the hell out of me. Trying to figure out what was this interface next hop. Do I need, what's this forward? So it was much easier to just learn and understand from, okay, if I configure the route, what does it look like? How is the router going to interpret this? So in order to ensure we've got this proper though, let's go ahead and I'm going to relog in here. This is the same credentials as what we're utilizing within Postman and Python. And you're just going to come in here and delete this static route. And instead of doing my verifications, which you should always do on here, I'm just going to run my get command again and ensure that yes, indeed, that route is gone. Okay, back to our set static route now. All right, we have the data, we have our headers, we have our response and .get, which we'll need to change, of course. And we've got our print statement. I don't really care what the router is going to send back at the moment, so let's go ahead and change this, because what I really care about is to make sure that response. I'm not spelling that properly, am I? Dot status code, not response code. I'm getting my terminology confused. And then I'm going to print status code, yes. So what I really care about is that I want to know that my router is sending back a 200 message so that I know that my call was successful. Now, as far as this method is concerned, we know it's not a get, and we know we want to put data into the router and we want to configure. So it's put, post, patch, one of those. Now we could just try all three and see which one works, or if we wanted to, let's go to the documentation here. And we notice we're looking at methods. We have these methods here, but there is this whole piece of RESTCONF yank patch support. So yank patch is an ordered list of edits that are applied to the target data store by the RESTCONF server. Yank patch operation invoked by sending a patch method request. That tells me that I should be doing a patch here, not a post or a put. A little interesting, since it's a new item in the list. Post may make more sense to you, at least it did to me. But as we're adding a component, it's going to use the patch method, sure. Okay. Now we can try to run this. And it's just one letter difference, so I'll just change that. And see what we get back from this, well, in this case, the router. Uh-oh. So 400, so we've got an error on our end that we're sending to the router. It's HTTP 400. Well, something pretty clear is that right now we're trying to send it a Python dictionary, which of course that's not going to work because we're telling it we're sending it JSON. So for ease, we're going to ensure that we change that payload there to JSON before we send it off. So let's see what else we have here. Oh, great, fantastic. So came back with a 204 specifically, which means it doesn't have anything else to tell us, but our call was successful. Again, we can quickly verify this with a get static route. And sure enough, there it is, exactly how we wanted to see it. A 10.100.100.0/24 to 17s with a name of our test route. And of course, if we wanted to do a verification, if you're more comfortable on the command line and look at it here, if I can put spaces in there, there we go. Yes, so we also see it here. So that worked perfectly. All right, back in the lab, we've actually skipped ahead task 4 and task 5 and done both of these. So print the response code, ensure you receive a 204. That's where we ended, fantastic. Task 6, clean up your code with Pylon, put it into a function, ensure it'll be called when the file is executed. Not going to do that during this video. It's not specific to do with RESTCONF. However, the solutions do have the file cleaned up with Pylon and in a function. So you can look at that and explore on your own. And if you're newer to Python, then this is a fantastic opportunity to just play with what you can do within the code set. And then task 7 is this is a public lab environment. Ensure you clean up your configuration. That's simple enough. We don't want to let our configurations persist. So let's, back in our router, we'll just remove this route. We'll give it a write, as is my habit to do after many, many labs. And now we'll move on. We move on to the next problem. I wanted to level set on the put, post, patch discussion. I mentioned the methods. I mentioned that if we're adding a new static route in my mind, why would that not be a post? Why would I have to use the patch method to do that? Well, that's my old school networking thought process, but not actually how the data was structured. So back in our programmability configuration guide, if we go to configuration examples, this actually gives us more information on those methods from a configuration standpoint. So to me, IP route blah 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 to create a static route was, well, that's a new static route. But we saw in the actual JSON data that that static route was part of a list. So we are not creating the list, aka the target resource. We were updating the list. And if you look at patch down here, we're updating the list, which is why we were using patch. So this gives you a nice example. Obviously, they do have some get and delete requests in here as well. And in the next section, and why I'm bringing it up now, we're going to use the majority of these to configure, ensure the configuration is in place, update if necessary, and then at the end, delete our configuration with an actual Python script here. So give those a read if you need to. Otherwise, we'll move on at this point. Okay, so here we are back in our lab workbook. We see problem 2 is set an IP address for interface gigabit Ethernet 3 on the CSR 1000V. Okay, we're going to dive straight into Python without using Postman. That's fair. So what is task 1 here? Create a new exploration script to retrieve all interface configurations from CSR1000V. Okay, and then we're going to update our script to pull from Gigabit Ethernet 3 primary IP address. Got it. So let's go over to our Visual Studio Code. We're going to create a new Python script, and I am just going to copy over our previous Python script here to get our interfaces. So we're going to clearly be changing this URL, and I'm going to add an endpoint here just to keep this a little simpler. And we're going to look at interfaces. Interfaces? You know what we can do here? We'll just look at this whole native URL first, and then figure out where our interfaces are going to be. So let's debug this script. And then we can scroll up to find interfaces. So there's router, crypto, etc., login, control plane. I'm starting to see interfaces now. Interface. Okay, so it is singular. And we see its interface, and then we have some gigabit Ethernets with key values here in the name. That's what we're going to look at later. So interface originally, so we'll add this endpoint in to our URL. Let's ensure that we can drill down to interface. Okay, so we pulled our interfaces back. And it did ask us to drill down to the primary IP address of primary IP address configuration of Gigabit Ethernet 3. So just following our data model here, we see gigabit, and the name is the key value here. So gigabit Ethernet, and that's going to equal to 3 because we're looking at Gigabit Ethernet 3. And then we can just see from Gigabit Ethernet 1 here, the next is IP, address, then primary. Let's go ahead and give that a run here. And let's see, URI key path not found. So if we look at response.status code and print our status code, just so, well, I do have to name that variable here. As expected, given the error message, we do get a 404 back. Now, why is that? Well, let's change this to 1 and see what happens. Still getting a 404 back. Interesting. Interface, Gigabit Ethernet plus 1 IP address primary. Let's scroll this back a bit. Well, it would really help if I spelled this accurately. Okay, then we'll go IP address primary. Really helps when you're making a point to make a mistake so that you can be like, oh, look, it's functioning, and then it doesn't work. Fantastic. All right. But it does if you spell it right. So Gigabit Ethernet 1 IP address primary, we obviously see a response here. It's a 1010-2048. Fantastic. But if we change this to Gigabit Ethernet 3 and we scroll again, or rather debug again, well, we see we do also have an IP address here. Now that is a remnant of my testing, so let me go ahead and quickly get rid of that in the router itself. We'll go ahead and log in. actually want that in there. So let's see. Give Ethernet 3. So this is the interface we're going to be working with. It's got no IP address on it now. That's what we want. And for the final time, to prove the point that I was trying to make originally before the misspelling and the remainder of the configuration, here we go. We still get a 404 error back from the router. Just one last time, change it over to Gigabit Ethernet 1, get it back. Change it back to Gigabit Ethernet 3, 404. If we take Gigabit Ethernet 3 down to just the interface, we do see we get it back, but note in this response there is no IP address. So when we actually add IP on here, since it does not exist, our get will return, oops, sorry, address primary. So once I add all that back in, we get a 404 because, hey, look, you don't have a primary address configured on this interface. Fantastic. All right. Okay. So update your script to pull the primary IP address. Does this fail? Why? Yes. What can the response tell you? It tells us that we need to create it. Perfect. So that's what we're going to do next. Task 2. So we're going to create dictionary, input the necessary parameters, configure Gigabit Ethernet 3 with that IP address that we saw, 10.20.2254. That's going to be a /24. So we could configure the interface and see how the router represents the parameters in Yang. Well, we kind of already did that accidentally, so we know what we should be looking at here. So let's go ahead and go back to Visual Studio Code. We're going to create a new script again. And again, no need to type all of this back out. We're just going to put this back in. Quick review, we are utilizing the request library. We obviously need to do some JSON data, as we're both content type and accept parameters are in fact JSON. And I'm adding URLib3 here just to disable the warning so that I don't get the constant, hey, this isn't a trusted site on my certificate. All right, so now we need to figure out what parameters we're going to use, but first let's add in our payload. So we're running Gigabit Ethernet IP address primary. We did see in our response that this is how we're going to do it. So we have our first value in here is this long key or primary, so that's just making it specific. All right, and then we're going to add in a new dictionary with our address, which is 10.10. Oh, that's not right. 10.20.2254. And our mask, which we said this was going to be a /24, so 255.255.255.0. Okay. All right, well, we clearly aren't going to be utilizing a get in order to do this. So let's look at our methods and see which one makes the most sense here. Let's see, we have our post to create. So this creates a configuration which is not present on the target device. Our put, which is create or replace. And then our patch, which is to update our request. Right, makes sense. So my inclination would be, well, we just saw that we got a 404 back. So why not use a post to create our request? If we put a post in here, okay, let's give it a try. As you can tell from the tone of my voice, I'm not too optimistic. I wonder why. Another important little task is the way that, this is still remnant from Postman, and they have the data in here as payload, but from our perspective, we're working with a Python dictionary, so we just have to ensure that we change that to JSON prior to sending to the router, or it's going to throw malformed message error at us. So let's give this a try. So unknown element, primary in our path here, we get a malformed message. So post clearly doesn't work here. To be honest with you all, I'm not exactly sure why, but I know with 400 error, we got to try something different. And that is on our side, so let us just use put. Much better, we get a 204 back, so it doesn't have anything additional to tell us. However, we know we were successful, and we can tell by running our get script again, and instead of erroring out on Gigabit Ethernet 3, we see we do actually get back our interface IP address configuration. Now, since this is put, and it can both create and update, if we rerun this script, we still get a 204. So we can run this script as many times as we want, and we get a 204. Fantastic. Okay, so we have successfully configured our IP address. Let's go see what's next. All right. Once you have successfully configured a device with IP address, try to rerun the script with a different method. Okay, so it wants us to use a different method now. So we created a proper call, we used the put method. Well, the only one that's left, because we know post doesn't work, is patch. So let's try patch now that our address is created. Okay. 204, okay, so patch also works. Now one could say that patch may be the safer option somewhat if we were going to be configuring this in production, as put is a desired state, if you will, so it replaces the configuration. So on a primary address, you're really only going to have one primary IP address on an interface, of course. But if we were in a higher level data structure that had multiple options in here, and we just said, oh, well, we just want to add this one option, and we're going to use a put command, well, it may add that one option, but it'll delete everything that is not included in the payload that you send the router. Patch, however, just updates. So this is a good way to add in a configuration. So one could argue likely that it is the safer method to use once the configuration exists. However, I think it should be evident that if we were to go into our router and log in one more time, and go into interface gig3 and delete this, well, once the address is deleted, there's nothing to update anymore. As we saw, our data structure was removed. So when we try to run patch, we're going to patch to a non-existent resource. So we have to go back to use our put method in order to add that, and then we can go back and use patch once again to update that now existent data structure. Okay. So we want to next build in error handling to your Python script to handle the situations discovered, both task 1 and task 3. Use simple print statements to output which method ran successfully. So what this is actually asking us to do here is essentially we want to use these 3 methods, right? So you should have a total of 3 methods. So given our conversation, that's essentially, okay, we're going to get the configuration. If the configuration exists, aka our get was successful, right? Because we noticed that our get, when that IP address did not exist in our device, it was unsuccessful. So we could use, in this case, a try except. So try, if that gets successful, we just use a patch. And then if it's unsuccessful, we use a put command. That way we've utilized all 3 and we've just had some good, honest fun with it. So I already have this pushed to the side. I'm not going to go through and recreate it. This video is already probably too long for your tastes as it is. This is available in on my GitHub. You can pull this down. But essentially, it does exactly what I just described. We have a try except block here, and it tries to get the response. And if the response is equivalent to the configuration that we have here, aka the address and the mask within the primary match, we're going to just print no update, existing configuration matches, and we move on. Else, so if the response comes back, so yes, the IP address exists, however, it's different than what we're trying to set, we're going to update it with the patch method, and then print the existing configuration has been updated. Now, if this try block fails, aka we do the get and it comes back, hey, that doesn't exist, it throws an error, we're going to then use our put method down here to create our IP address and then print this statement. 2 things of note here. Additionally, you see this is rprint. I've imported the rich library and imported print from that library as rprint, just to give it a little bit more pizzazz, if you will. You see the green here to print so that you can see a success. The second thing here, if we go back to our task, is on task 6, we're creating an interactive method. So what that essentially is I've actually asked the user to input the address and mask here and save their responses and utilize them within our config value here. So feel free to play with this, go through it on your own. Like I said, it's on the GitHub page. You can download it and look at it. We can run this, and I did create this so that you can set gig3 p.py. All right, and we're going to, we have a couple test cases we could do here. So well, maybe we should save this first. There we go. Enter IP address. Well, we know we have this existing already. So we should have no update. That's what we want. And this is that R print here. It just gives it, you can do a lot more than just color, but that is, just gives you a nice green, hey, this worked. The existing configuration matches the configuration attempted. Okay, fantastic. We knew that, right? We had just configured that interface. But let's say, oh wait, this was supposed to actually be a /25. So 10, 20, 20, 254, and we actually wanted it to be a /25 here instead. Well, that's no longer going to match because this was a /24, so as expected, we're updated. The existing configuration has been updated. Fantastic. Now, if we jump ahead again, we're going to remove our configuration. We're going to do that with a delete config. So let's do this, and we need this to test our final case here where the IP configuration does not exist in the first place. So we're going to, and I'm just going to, again, copy this over. And instead of a delete, we'll use, or sorry, instead of a get, we'll utilize a delete here. Let's see if that works. Ah, perfect. We get back to 204. Just to be clear, we'll run our get interface one more time. And yes, a 404, which means our IP address doesn't exist. So one more time, we'll test out our setgig3 IP, and we'll put back in our interface or IP address here. And our third option of created pops up. Okay, perfect. So that's all three cases we've proven out. So we've no update. So if we're putting the same IP address back, it does not update it, just moves on. Our patch, so we've utilized our patch parameter that if it exists currently, just update that specific configuration, and then put is, hey, if it doesn't have it and you failed on the get, go ahead and accept with this put command and configure it, or in this case, you could say create it as such. So we'll run our delete one more time, ensuring we get a 204 back, which we do. If you're paranoid, you can go into the router again, and this does kick you out very quickly. A very short timeout. And look at gig 3. So we've cleaned up our interface. We have no remaining configurations. Back to our lab. Remove your configuration. Okay. And that's it. We're done. All right, so there you have it. We started off in Postman, utilizing that software to help us build an API call to understand the Yang model a bit better within the iOS XE platform. We moved on into Python to configure a static route, and then we came back to the interface configuration to add, update, delete an IP address within that interface. Hopefully you've learned a lot. I did. Going back and reviewing this lab, just doing the put, patch, post, get, delete methods, and understanding which method was specific to which situation within the data model that's presented to us was very informative. So hopefully that helped you as well. If you have any additional comments, you can put them down below in this blog. You can message me. Additionally, make sure you go to my GitHub page to pull down the solutions. And again, if you find anything in the solutions that are wrong, I have tested them, but of course they may be. Always feel free to let me know. But otherwise, I hope you had fun today. See you next time.